Right, well, this is going. Good morning, everyone. I'm very excited to be here. This is actually my first in-person conference since Corona, and this may be your first in-person conference since Corona. So there's nothing quite like doing something on stage in person, and I really thank you all for coming along today. All right. So today I'm going to be talking about building architectural fitness functions, which is part of building evolutionary architectures. Let me see if I can get this connected. All right, wonderful, excellent. As Manuel was saying, I'll be talking about architectural fitness functions, which is only one part of building evolutionary architectures. And there's a lot more to this, so please keep in mind it's not just about the fitness functions, even though that's what we're going to focus on today. My name is Patrick Hua. I'm based in Berlin, Germany these days, so not too far, and I've been working in technology for about 20 years. So it's kind of interesting to see how much of our industry has really changed over time, from everything from waterfall to more agile, from very batch-based software development to very continuous delivery, hardware to sort of cloud-based software systems. So a lot of evolution, and this is one of the reasons why we ended up sort of capturing this in terms of the book, Building Evolutionary Architectures. So if you want to learn more, you can go look at that on O'Reilly. We're actually working on a second edition as well, updating this based on lots of examples and use cases that we've heard throughout the years. But as Manuel was saying, I was working with ThoughtWorks, and one of the things I used to do as a consultant was hear about people's different organizations. And I'm sure you've got lots of systems that you wish you could evolve a lot quicker. And what we wanted to do was really capture some of the ideas behind how you can do that and some of the principles and practices you can use. The one that I'm going to be focusing on today is really about the fitness functions. And to go back to this idea, I want you to think about, what does software have to do with gardening? Kind of a weird metaphor, right? But it kind of connects to this whole thing about evolvability. Now, if you have gardens like this, I'm not actually a real good gardener in real life. I'm much better with software. But you're going to end up with different types of gardens, and it's kind of interesting to sort of think about what type of garden you would like to have. But there is one thing that's true about most type of gardens, is as much as you can plan, nature will take its course, right? You're going to have droughts, you're going to have lots of probably rain, there's lots of things that you can't really predict. And this is very true about the nature of software development as well. As much as you have that lovely architectural plan or some design that you have in mind, something is going to come along and disrupt that. Be it about the business, be it about new technology, maybe it's something about your plan that you thought looked good on paper, but doesn't actually really work once you actually start putting this into practice. Lots of great ideas, but you have to adapt to the environment as it comes along. The other interesting thing that I think really works quite well with this metaphor with gardening today is gardens are never really done. They continue to kind of grow. And you can think about aging old systems where maybe you start to layer other applications on top of things, and you can almost see the generations of software throughout your system, and therefore also the different types of layers in your garden as well. We start where we start, and we have to continue working if we want our companies and our software systems to really continue to add value. And so this is really some of the ideas that we really wanted to bring into building evolutionary architectures. It's kind of this idea that if you want to design this perfect architecture, you need to have this perfect understanding of the future. And how many of us can do that? How many of you have a crystal ball? If you did, you probably would be able to win the lottery, and you wouldn't necessarily have to be here. So this is the idea: if we can't really predict the future, then it's going to be impossible to design the perfect architecture. We won't be able to predict what our customers will want to do. We won't be able to predict what our business would like to do. We might be able to make better decisions about what we would like to do, but even we can't predict what tools, technologies, and sort of techniques will continue to evolve that we can take advantage of as well. And so this is kind of the idea that if change is inevitable, what would this mean if we were architecting systems designed for change as a first principle? And that's really the essence of what we wanted to cover with building evolutionary architectures. Now, this is the overall definition of what we think is about evolutionary architecture, one which is a incremental, guided architecture that uses these things as a first principle and is optimized for multiple dimensions, optimizing for change around business, but also optimizing for change around technical components. As I said, the book goes into a lot more detail about how to do that, but one of the things that I really wanted to focus on was this idea of fitness functions, and this is really touching upon how you guide software systems in what you think you would like to actually have. So if we go back to this idea about software being a garden, what you should all be asking about your companies, about the type of system or application that you're building, is the question of what sort of garden would you like to grow? Now, the wonderful thing about this metaphor is that we've got lots of really great examples of many different styles of gardens. So you're building something designed for the desert, something that's a little bit more tropical, something that's very lush like you get here in Vienna. There's many different styles of gardens, and none of them are necessarily better or worse than the other. They're just optimizing for different things. And this is also very true for software systems, is that we really want software systems to be optimized exactly for our use case, for our domain. And even within our own company, we might be optimizing for different traits. So if you're building your software system for your end customers, it needs to probably be scalable and secure. That may not necessarily apply to an internal application used by 3 or 4 people in terms of back office operations. So you should be asking yourself, what does the system that you're building look like, and what should you be optimizing for? So what sort of garden are you trying to build? And this is where this idea of architects or people who might be playing an architect role should think of themselves as software gardeners, right? Thinking about what sort of landscape that they're trying to build and trying to create the right environment to foster the type of systems that you're actually trying to develop. But when I think about many classical software architects, I like to ask the question, how do they garden? Now, I think software architects as a role tend to have a little bit of a negative connotation. In a lot of organizations that I consult or coach with today, you tend to have less of a software architect role. You might have tech leads or staff engineers, but there's something a little bit negative about the software architect role because of the way that they normally work. And when I think about classical software architects, this is kind of the picture that comes into mind. Judgment, right? They might say things like, you can't do that, or things like, no, that's wrong, or something like, you must do this, you must use this framework, right? And if you're in a team, you're working, trying to build software, you don't want to hear these sort of statements. Nobody really wants to be judged, and it's impossible to really judge everything today. If you think about the pace of software development today, teams are constantly writing new things. It's impossible for one person to go around and try to judge every decision that each individual developer are making. So it's not necessarily a scalable function. And when I think about this approach, there's a couple of key concepts that I think underline why it doesn't really work. One of them is this idea of autonomy. So if you're familiar with Dan Pink's Drive, we talk about this in agile teams, of teams being able to make choices, but there needs to be some level of autonomy, and this kind of policing or judging sort of strips a lot of that away. Another reason why this tends to fail us in software is this idea about context. So Simon Sinek's Start With Why. I'm a big advocate around technical leadership, and one of the key principles I try to teach for technical leadership is always starting with why. What is the purpose? What is the value? Not start with the rule or the thing that you can or cannot do as well. And so this classical approach to software architecture doesn't work, and it doesn't necessarily scale as well. And so it's interesting, because rules and constraints are important, right? So there is a purpose to guiding a garden explicitly, but it's more about the mechanisms of how you go about doing that. So when you think about what does nature do, going back to our gardens, how does nature approach this problem? Nature doesn't have police people going around saying, you can't do this to plants and animals, right? It doesn't really work that way. Instead, the way that nature does this is they think about what is fit for environment, evolvability. Those things that survive in a certain environment will thrive and reproduce. Those things that are not necessarily fit for environment will tend to reproduce less or eventually die off and therefore not be necessarily fit for environment. And this is really the idea that we wanted to have with fitness functions, right? Thinking about what does good look like and trying to focus on the environmental constraints, but allow people in that environment to choose how they would actually fulfill those constraints as well. And so for us, the idea of fitness functions is this idea about guiding software architectures with this idea. And what I would like to leave you with was this idea of this short recipe about how you might think about fitness functions. And we'll go through some concrete examples so you understand what these look like in real life. So let's first start off with definition. So what is a fitness function? It's an objective function that measures how close a given solution fits to a particular goal. If you're familiar with sort of machine learning algorithms, right? So as you train an algorithm, you're not telling it how to go about solving these things. Instead, you're trying to say, here is what a good solution looks like, using lots of training data. You focus on what does the objective output look like, or the outcome, rather than talking about the algorithms or how it goes about approaching it. And that's really the idea of fitness functions, is really trying to focus on the objectiveness of what does a good solution look like. So if you think about your software systems, how would you describe what does a good software architecture looks like for the type of system or application you're trying to build? The more you can objectively quantify this, the better you are at actually defining fitness functions for that. Now, we do get a little bit of confusion sometimes about, like, is there one or many? And it's kind of a sort of granular, you can have one fitness function composed of, like, all these small ones. And we'll go through some examples. But what's important here is that you focus on being as objective as possible and trying to clarify what does good look like. So in order to think about building fitness functions, the first step that you want to do is identify what you care about. Right? So for your software system, for your application, for your domain, you want to actually list out and think a little bit about what is important for your application. So you might think about these characteristics, and there's lots of examples of these things out there. These things are sometimes called system quality attributes. So these are the quality attributes we want in our system architecture. I like to call them cross-functional requirements because they cut across the entire system. And a lot of people are often familiar with these things called non-functional requirements or the ilities, but I tend not to encourage those sorts of words as well. The important part here is that when you think about architecture, these things are still important because these are characteristics which also have some trade-offs depending on what you're optimizing for. Now, in my experience, because of Agile and because of this idea of moving away from, say, waterfall, there seems to be a sort of trend of not doing any upfront thinking with system architectures. And what we're trying to find is a good balance around this, right? So we're not saying that you should go off and spend 3 months building and planning a perfect architecture, but it probably makes sense to sit down at the beginning of a new project or an initiative and actually spend a day or an afternoon trying to talk about your domain and trying to map out what is important for your characteristics for this software system. Based on these things that are important to you, then you might be able to actually quantify and classify what does good look like for each of these traits. So for some type of applications, some of these traits might be important, and for other types of applications, the things that are less important might be important as well. And so in my experience, a lot of developers, when they're working on systems, they don't really have a good view about what are these bigger, broader characteristics you're trying to aim for, because they're often focused on features or tasks, and they're not really thinking about the broader sort of picture. So step one is providing this good context about what does good look like and trying to objectify these things as much as possible to quantify them into some substantive sort of goal. So when you think about what is important, for instance, in Netflix, they're very well known for resiliency. Right? So when Amazon S3 went down, Netflix continued running really well because for them, they've really invested in resiliency. If we think about some of the other tech giants, if I think about, say, Amazon, they optimize for things like moving fast in terms of sort of innovation, speed. They talk about 2-pizza teams, independent teams, and about sort of experimenting, which might mean failing fast as well. If you think about something like Google, some of the things that are important for a lot of their products is this idea of strong consistency, right? So a Google product looks like a Google product. And one characteristic that they tend to have is that they want to scale a product to all of their user bases pretty immediately, which is why they're very intense in terms of the algorithms and performance of each of their different systems. But when you think about what is important for each of these traits, there's also going to be some trade-offs. And this is an important thing to also articulate. So if you think about Netflix and their resiliency, one of the interesting trade-offs they have there is that it's simplicity, right? It's a complex environment when you're actually building applications in Netflix. Is that if you want to deploy a new service and you want to experiment with something, there's a lot of things that kind of get in the way because you were trying to build resiliency in, and therefore it may be difficult to experiment. And so you end up with this trade-off. If you want these resiliency sort of mechanisms, you have to trade off some level of simplicity. If you've ever worked or probably dealt with a lot of the Amazon APIs, one of the biggest things here is inconsistency, right? Like, which API should I be using? Which service should I be using? Why does it feel like different from things? You'll notice that there tends to be a lot of duplication, and it's sort of an inconsistent developer experience because it really feels like you have different teams working on different APIs. And as a result, you kind of have these trade-offs because they're optimizing for these fail fast and moving quickly. Now, because Google is kind of the other extreme of strong consistency, one of the things that they have here is high coordination costs. One of the consequences of this is they have their Google mega monolith of everything in the same code base, which requires them to have special source control systems, special IDEs, special tooling to be able to do everything. But it does give them the advantage of when they want to make a change across their entire product suite, they can literally do a static analysis and understand which products are going to be affected by what, and make large sweeping changes. So none of these are necessarily better or worse. They're just different, like different software gardens. And so you need to be thinking about, for your software application, what type of garden would you like? And there's definitely going to be some trade-offs, and make some of those trade-offs explicit, because it's impossible to have everything perfect in software. The other important thing here is thinking about how systems change over time. So Manuel mentioned about how I was a former CTO and chief scientist for N26. You see this in startup land, where in the very early stages of businesses, this is the lean enterprise sort of world, you might have the exploring sort of world, trying to find new market fit, trying to find a sort of customer need, and you want to actually test if people are willing to pay for that. Once the startup is sort of relatively successful, you end up in what they call the exploit phase, or sometimes the scale-up phase, right? In that sort of case, you're probably optimizing for different needs because you've now found that sort of market fit. If you go into the sort of sustain phase, you can think about this as a well-established market. You've got large market share. It's not growing rapidly. You want to optimize for different traits there because you're trying to sustain things. And there's obviously the retirement, which probably doesn't happen so much in teams and products because there's a lot of old software lying around. People are unwilling to decommission them. But what's interesting here is as you go through these phases, you're optimizing for different traits. And Facebook's a really good example. If you think about the early days of Facebook, they used to have this motto of move fast and break things. Right? This was very much in the sort of explore and exploit type of phases of we want to capture the market. It's okay to break this as we try to gain the status of world #1 sort of social network. But even for them at some point, one of the interesting things they changed was realizing we were breaking too many things. A 5% breakage on our system affects millions of users. Maybe that's not such a good thing after all. And so one of the things they ended up doing was sort of rebuilding this and sort of saying, okay, well, now we're in sort of sustain. We want to move fast with stable infrastructure. Not as catchy, but it kind of does the point of saying we no longer want to optimize for just speed at the cost of errors. We want to make sure we actually have some good, stable infrastructure as well. And so you'll also need to think about the lifespan of your system, about the phase that your product is in, because it's not just about what you would like, but also about that sort of lifespan of that system. All right. So step 1, make sure that you think about what is good. And then step 2 is actually defining what does good look like for each of these different traits. So as an example, if internationalization and localization is important for you, you might say things like, well, we want to optimize for more than just one language, right? So we want to put in localization, translation strings, but maybe we don't want to optimize for non-Latin languages because that's an extra level of complexity. Now, some of the reasons for this is maybe your target audience is here in Western Europe, so it's not necessarily so important around sort of Eastern sort of Asia or sort of other Arabic sort of countries. And one of the interesting trade-offs here of internationalizing an application is you're going to have longer content cycles, right? So if you're building a new page, you have to go and get things translated. You have to make sure all those translation strings work quite well before you actually go live. There is an important trade-off that you're going to have there. But in this case, we want to make sure that we've got 10, 15 sort of sort of English-based languages, all Latin-focused, and this is what our good system looks like for our architecture. Maybe one more example here is let's maybe optimize for deployment speed, right? So this is a very common thing that you see in a lot of applications today. And so good might look like we want to move from monthly releases to we want to be able to release more than 5 times a day, right? So you're defining what does good look like and make sure that there's that sort of step chain in around your target goal here. In this kind of case, one of the reasons behind this, which is why a lot of companies want this, is you want to have a quicker turnaround on bugs. If you find a security error or a security issue, you want to patch it as quick as possible and make sure that you can actually get this out. But once again, there's going to be some trade-offs, and the very common trade-off with improving continuous delivery in this case is you have to invest in the automation. Right? You have to perhaps even invest in re-architecting systems that were not designed to be released so regularly. It often also has an impact on how you design and write code so that people get used to dripping work in incrementally, using feature flags to turn off sort of features, but there's also a sort of impact to some of the development processes as well. So define what does good look like and define what is important for each of those traits. One of the reasons this is important is over the way that we think about sort of software products in the product management space, you often hear about this thing about outcomes over outputs, right? So if I think about very progressive software development product companies, product managers are often working with software development teams to think about what they need to build. Product managers aren't prescribing user stories and features. Instead, they're talking about, here are business metrics that we're trying to adjust, and involving the whole team around what can we do to actually drive these outcomes. You might have heard about things like hypothesis-driven development, where everyone is putting together a hypothesis of saying, if we put this feature in, we might expect this maybe a conversion rate from signed-on customers to paying customers to increase by 1%, right? Which might be quite significant. And so there's this idea of sort of outcomes over outputs, which is a big trend in the product management space, but we don't really see this in the sort of technical leadership space as well. So if we go back to the software architect who's telling you what you can and can't do, that's often really focused on the activities or the outputs, not about the outcomes. And so this is one of the reasons why fitness function is so important, is that today it's what does good technical leadership look like here on defining what is a good outcome that you're trying to reach, and allowing teams to perhaps be a little bit more flexible about how to reach them. All right. So we've looked at defining what is important, defining what does a good outcome look like for each of these important architectural traits. Now you want to think about fitness functions, which is how you go about reaching these potential outcomes. So fitness functions for me are about providing guardrails. It's less about sort of providing sort of rules and regulations, but trying to make sure that when people are working in teams, they get fast feedback around those characteristics. So I want to make sure that we go through some concrete examples so you understand what these look like. And there's a couple of different sort of traits. One of them is that some of these can be manual, but we do prefer encouraging you to think about automation where possible, because these things will be a lot more scalable than having somebody judge every sort of decision or quantifiable trait. So think about the things that you can automate when it comes to fitness functions, and we'll have examples of both examples. All right. Let's go through some of these use cases. So imagine that you have this challenge that you want to get all teams to build resiliency in, right? The Netflix challenge, right? So in this sort of case, building a streaming service that is used worldwide, we can't afford major downtime. Therefore, we want to make sure our systems are as resilient as possible, right? This is an important architectural trait that all teams need to go about building into their system architecture. Now, if you were the CTO for this company, how would you go about enforcing this, right? So the naive approach here is let's add a testing team, and then for each time that somebody is going to make a change, we're going to run some resiliency tests. Very normal approach, right? Very common approach. And so you might have these product teams, each building services, applications, and you have this poor little testing team that's like going off and running resiliency tests. Can anyone spot a bottleneck? You probably don't really want to be on that testing team in this sort of growing organization. It's going to be a lot of stress, right? So you're going to be, and this is a very human approach around, we have a problem, let's throw more people at that problem, but it's not necessarily the best approach to something like this. Right. So this is not the desired or recommended approach. So can we scale this somehow? Yes, we can, and we want to do this through automation. And this is really the idea of the simian army. So if you're familiar with the Simian army, it's a collection of tools that Netflix developed that allows people to basically automate the process of resiliency. These tools are constantly running in production, and some of the tools do things like simply turning services on and off, right? Other tools do things like slow networks down to sort of see what happens, or to cut a network off shortly to sort of see how a service might actually resolve with each of these different elements. It's a collection of different tools that are constantly running in production. And so this means that if you're building a service and you try to deploy that service into production, your service is not going to hang around for very long, right? Your service is not very fit for that environment. And so you might do this for the first time, trying to test an MVP or an experiment, but you'll learn pretty quickly about, oh yeah, we forgot to maybe do some retries, or we forgot to do some things like timeouts to make our systems more resilient. Right? And so your team will hopefully improve that and build more resiliency things in, and it's being informed through the environment is that it's not necessarily fit for purpose. So this is a really good example of a good fitness function that helps you think about resiliency. Now, for us, this is a good automated fitness function, right? Because nobody is sort of running this. It's running automatically in production. This thing is a continuous fitness function because it's constantly running in production, testing new services as they get deployed, but also as services are running existing in production, making sure that things break constantly as well. This is also what we describe as a holistic fitness function because it's testing the system all integrated live into production. So we have other types of examples of fitness function that aren't necessarily the same types of traits. And in the book, we describe the categories of different types of fitness functions that you might have. But this is a really good example of an automated, continuous, and holistic fitness function. All right. Of course, there are some trade-offs with this approach. One of them is somebody has to build a simian army, right? If you're trying to take advantage of these, you probably need to set them up and make sure things are running quite well. And one of the other aspects here is it's generally slower to innovate, right? So if you're trying to put an experiment out to a smaller audience, then you have to think about building resiliency in from the very beginning, which is going to add to that initial sort of test phase for you to actually get things live. All right. So a very common sort of approach, if you're thinking about good architecture, you think about good layering, right? Common architectural challenge, right? So in this sort of example, you might have different layers. You want to make sure that people are following those layers. A naive solution here might be doing something like code reviews, right? Adding a step into your code review process to make sure that we're following good layers. You might do an explicit design review as a team or as people are building stuff. And sometimes you might do an architecture review, so more sporadically, to sort of test to see how well are we doing to our layers. And we might spot one team member who tends to violate these sort of principles because they're just doing the simplest thing that they can for a particular feature. Now, these approaches, once again, don't really scale and not necessarily the recommended approach. So if you're trying to have something like a layered approach where you have these different layers, this is kind of the best pattern, right? It's unidirectional. A bad pattern is where you have cyclic dependencies. So in this case, utility is calling something into the web layer because then it's a lot more coupled. It's a lot harder to actually break things out. So the interesting question is, how would you go about enforcing this sort of good practice as a fitness function? So when I was writing code, way back in a while, one of the ways that we might do this in Java world was using something like jdepend. So jdepend analyzes dependencies of imports, and you might run something as a simple unit test as part of your build process that says, remove cyclic dependencies. Right? And that test is then in the build. If somebody adds in a cyclic dependency, they will get some fast feedback to make sure that they think, oh, I didn't really think about these layering. Maybe I have an incorrect sort of function or an incorrect sort of design. Maybe I need to redesign something so I think about which layer some of these functions should exist in. Now, this is a simple test, and you might be even more explicit, and this is something that jdepend allows you to actually do, is then to actually define the layers that you would like to have, and explicitly define which layers can actually call each other to make sure that you have the correct levels of dependencies. Now, Java has moved on since then, and one of the interesting things is that there's many different ways you can implement this. So you have the idea of the fitness function, but you can have different implementations. And since Java 9, you have the idea of modules, and you can do things like explicit module dependencies, so which modules can call other dependencies or other modules. And so you can actually enforce this in a different way as well. What's important here is that you have the idea, and you think about the fitness function implementation, but you don't have to be too strict on the implementation. Of course, every language will have its own different approach to tools to do this, but the same concepts apply, right? So this is a good example of what we call an automated sort of fitness function again. This is a little bit different in that it is a triggered fitness function. So you don't need to run this continuously. You only really need to have this fitness function running when somebody is making a change, right? So this is why it makes sense to have it part of the build process rather than running in production, because it's only when somebody is making a new change that they might potentially violate some of these layers. This is also what we call an atomic fitness function because it's only testing one architectural trait, which is really about this layering and package dependency. All right. So a very common challenge, many of you are using microservices, and one of the common challenges here is, particularly if you're on the ops side, is how do you make sure every service is monitorable, right? If you go the extreme autonomous way, you might have, you build it, you run it, and every team can build their own monitoring solution. But that might mean that everyone has their own monitoring stack. They might have different ways to monitor their services, which makes operations a bit of a nightmare. And so, the naive solution here is you make it a requirement, right? So you say before you finish a story or whatever, this thing needs to be monitorable. Of course, then once you have that as a requirement, there needs to be a check. And so this is about inspecting, have you actually got a monitoring acceptance criteria signed off? And once again, this is the idea of this right or wrong, which isn't necessarily a good, preferable way around this, right? So it feels a lot like judging. And this is not necessarily the way that you would best implement this type of fitness function. Instead, one thing that we tend to sort of think about is putting more checks into your build pipeline to improve the checks that you care about for your sort of system here. And so in this sort of example here, you might thinking about your general build pipeline is that this is a very typical sort of compile, you run your tests, you deploy your system somewhere. And in this sort of world, you probably want to run some deployment tests as well to make sure your system has the right types of traits. Only once they're ready do you have good release candidates. And so this is a really good area to really invest in if you're thinking about automating fitness functions and putting this into your build pipeline. For this type of challenge of trying to make sure that every service is monitorable, you might have something as simple as this, an automated test that is checking that at a particular service endpoint, there is a status page or a location that is responding to 100 OK, right? That might be the simplest thing that you could do to make sure that there is something ready to be sort of monitorable. You could obviously expand this into the details, so you might actually check, is it JSON, does it have the right sort of fields? You might have other types of information that gets collected and pulled into a dashboard. But we're running this test and making sure that every system adheres to this, makes sure that you're saying, here is what is expected of what good looks like, and then teams can work out how they go about fulfilling that as well. Right, so you can't go to production until this test passes. Teams can choose how they'd like to go about implementing their monitorable solution, but there's a nice interface that can be shared across your entire organization without one person coming along and saying you're doing it wrong. Right? That doesn't really scale, and nobody wants this. Okay. So this is, once again, a good example of an automated, in this case, a triggered again, and again, an atomic fitness function as well. So very useful type of approach. One final example I do want to cover is how do you make sure that content is understandable? Content's a really hard topic because content is subjective, right? We interpret content kind of differently. And I wanted to include this example because it's a very different flavor of a fitness function for us. So think about your government websites. I have no idea what it's like here in Austria. I live now in Germany, so they're very often very bureaucratic, very hard to understand, lots of complicated process, and what comes to mind when you think about this? For me, when I think about government websites, you tend to think about things like this, right? Like you have to trawl through a lot of things to try to work out what you need to go about doing. For me, a really good example of a good leading government that is doing this really well and keeps a fitness function in mind is the GovUK, so the UK government website. As part of their content guidelines, they have this rule or this guideline of this is, designing content should be designed for a 9-year-old child. Right? So when you're thinking about building content, this is your target audience in mind. This is really interesting because when I look at some of the government websites, and I took a couple of examples here, there's an example of renewing your passport, right? So to renew online, this is what it costs, and here are 3 things that you need. On the other side, it's here is the process. It's very clear and simple, right? And that's kind of the goal of what does good look like. But the interesting question is, how do they go about sort of keeping this as a fitness function? Now, because this is subjective, it's not something that you can really run a lot of automation for. And so in this sort of case, one of the things that they have is it needs to be a manual process. So they actually do user testing with content. So when they're going through changes, they run through their content and actually test it for readability, right? So is this hard to understand? It's not necessarily about a 9-year-old. You might have adults who are not so well educated, which mean that they don't have the same rich vocabulary or comprehension of a lot of the bureaucratic or more complicated terms. And so they tend to do more manual user testing through their content when they're actually doing things. In this sort of case, because it's more manual, it will typically be more periodic as well. So it probably doesn't make sense when you change one page to simply do another test. They kind of need to think about batches of changes and then think about how do they actually get that user testing in. And once again, this is only testing the readability side. It's not testing probably for accuracy. So this is one trait of being a manual, periodic, and atomic fitness function. So I want to wrap up because we're running out of time, and I want to remind you that evolutionary architecture is more than just the fitness functions. It's about building architectures that are incremental, guided, change as first principle across multiple dimensions, helping to improve both business and technical changes. And for us, guiding also means thinking a lot more explicitly around fitness functions. Prefer automated ones where you can, but it's not always possible. So I would like to leave it open to any questions that you have.